video, we are going to find the regression equation and predict the value of a car given the mileage and value of 6 cars that were recently traded in. We must look at our data. We notice that we have 2 streams of data. We've got the M, which stands for the mileage, and we also have the V, which stands for the value. Now, in terms of algebra, graphing calculators, we want to make sure that we understand that the M, or the mileage, is also associated with the X values, and the value is associated with the Y values. And our graphing calculator, the X values will be associated with list 1, and our Y values will be associated with list 2. Our question here says, what will the value of a car be if the mileage is 13,258? So since this is the mileage stream of data on the top row, that's basically where that would fit, 13,258. And it says, what will be the value? That's what they want us to find out. They want us to find out what number would actually be in the chart in that position and represent the value of a car that has a mileage of 258 miles. So let's go over here to our graphing calculator. Let's turn it on, and we are going to go find the linear regression function. We will find that on the stat button. If we look at the stat button here, we're going to push that. And the first thing that we're going to do, though, is enter our data. So when we enter data, we're going to edit some list. So we're going to choose the first thing that pops up. Edit 1, edit, yes, that's what I want to do. Okay, so if you notice, I have already put the first row of data. All the mileage has been entered into L1. So I'm going to do my right arrow, and I'm going to start entering in L2, which will be my Y values, or the second row of data. So let's go ahead and do that. 16,921, enter. 10,300, enter. 7,225, enter. 5,300, enter. 3125, enter, and 1800, enter. Okay, so we want to generate our linear regression equation first. So we've entered all the data that we were given up front. So now we're going to go out of that. Second blue button, quit, gets us out, but we're going to go back into the stat function again. But this time, instead of editing a list of data, we actually want to do some calculations. So that means we're going to right arrow to where it says calculate. And at that point, we're going to see a list of calculation options. Well, we've already been told that this was a linear regression. So we're going to go ahead and look for the option that looks like it's talking about linear regressions. And that would be number 4 down here. Number 4 says linear regression. And we're going to choose that. And at this point, it says X list L1, and it's basically saying, are your X values in list 1? And we're like, yes. Are your Y values in list 2? Yes, they are. That's what I want the calculations to be made with, list 1 and list 2. So I keep pushing enter, 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 and then once I push enter on calculate, it will do exactly that. It will calculate for us. It gives us this format of Y equals AX plus B. That is exactly the same thing as Y equals MX plus B. There's no difference between the A and the M in the format that we're used to seeing and using. But this tells us what the A value is. It says that the A, which would be the same as the slope, or the M, is going to be equal to negative 0.0905. Okay, and then it says my X is going to remain an X, but then it gives me a B value. It says that my B value is going to be 13888. We'll leave it at that. Okay, so, and this basically means that the line has a starting value, car value of 13,888. So what we're accomplishing by this is that these numbers that we're given in real life do not line up perfectly. They do not make a perfectly straight line. So what we are doing, we are coming up with this equation, which is a line. If we graph this, this will give us a line. And this line will go approximately in the middle of all this real life data. So it approximates the data that we're given. So linear regression basically means we start out with data points and we are going backwards. We are regressing and going backwards to find the equation that would match with that data as closely as possible. It will not be a perfect match, but it will be close. And then we can use that regression equation to predict other values, and that's what we want to do. That's what they want us to do over here. They want us to predict what is the value of this car when it has a mileage of the 13,500 or 13,258 miles. So the thing is, though, is that our mileage is associated with the X value. So that means where this X is where I'm going to put this mileage figure. So it's going to be Y is equal to negative 0.0905. Let's go ahead and reduce that number to just 2 decimal places. Let's go ahead and change that. We're just going to make it negative 0.09, and we don't need all those decimal places, so let's do that. And then where the X is we're going to put our mileage. They want us to consider a car that has mileage of 13,258 miles, and then plus 13,888. Okay, so at this point we are going to go back to our graphing calculator, and we are just going to calculate this total. So second quit gets me out to a clean screen, but now I can just literally do minus 0.09 times my 13,258 miles. Oop, I think I messed something up there. 13,258. There we go. Got it all in there this time. And then plus my 13,888. And the number that I calculate is that my total value on my car is going to be $12,694.78. So that could be rounded to what number? My value could be rounded to approximately $12,695. So that's a good approximation of what the value of my car is going to be if my mileage is at that point. So I can, if I want to kind of see how it fits in, this would be the mileage, and they predict that the value of that car is going to be $12,695. So I hope that that helps you see how to use your graphing calculator to come up with a regression equation, which helps people make predictions in real life. Click on the like button, click on the subscribe button, and we'll see you back soon. Thank you.